everyone. The last video we ended just looking at acids and bases and their strengths. So we just looked at this table saying that if we have a strong acid, then its conjugate base is going to be weak. And so that's what this table shows here. And we know the conjugate base of an acid looks similar to the acid minus a proton. So it loses that H plus, and therefore it goes from neutral to negative. Okay, now we're going to take this a step further. So another thing that we discussed was when we have an acid and a base. Okay, remember an acid is a proton donor. A base has lone pairs and is a proton acceptor. That's our Bronsted-Lowry definition. Okay, if we have equilibrium, okay, arrows here, that means that we're dealing with a weak acid because there's not complete dissociation. Okay, if you need to review the previous video, do so on that topic. All right, so the position of the equilibrium, it's going to depend on the strength of the acids and bases. So whether there's more products being formed or whether there's more reactants being formed depends on the strengths of these acids. Okay, so I have this starred, so this is very, very important. For a reaction to occur, an acid-base reaction, the stronger acid and the stronger base are going to form the weaker acid and weaker base. And so I tell my students that the reaction drives to the side of the weaker conjugate acid. Okay, so the reaction is going to proceed in the direction. So we have two directions it could go. It's going to proceed in the direction of the weaker conjugate acid. So that's what I look for. So a reaction, abbreviate here, drives to the side of the weaker conjugate acid. All right, so when the stronger acid and base are the reactants on the left, the reaction is going to readily occur and the reaction proceeds to the right. So here, if you look at the products, okay, so we would say that this is product favored. Okay, we don't have actual acid and bases in here, so we're just trying to get the concept first. Okay, and therefore you see this arrow is larger going towards the products because more products are formed. Okay, so if the reaction is going to proceed in a way so that it drives to the weak acid. Okay, if the reverse is true, so if our reactant is the weaker acid, okay, then the reverse reaction is going to be favored. Okay, so this would be a reactant favored reaction. Okay, and so you'll see that that arrow is larger than the product. Okay, so but the idea is the reaction drives to the side of the weaker conjugate acid. Okay, so now we're going to actually put in acids and bases into the reaction, and we're going to determine which way is the equilibrium favored. All right, so we have our acid and our conjugate base. So we learned how to pair these in a previous video. And then we have our base and the conjugate acid. So our acid loses a proton and it becomes this negatively charged cyanide there. The base gains a proton and becomes water. Okay, so the first thing you have to be able to do is look at this and label your acid, your base, your conjugate base, and your conjugate acid. And what I tell my students is to look at this. So you're going to be comparing the strength of your acid and your conjugate acid. And the reaction is going to drive towards the weak acid. Okay, so first step is identify. You have to know what's your acid, what's your base. Okay, now I'm going to show you the table. You can find this in any book. If you're in my class, we're using this table, but you can be anywhere. Okay, and you're going to compare the HCN and your conjugate acid. Okay, all right, so here's our hydrocyanuric acid here. Okay, so that was our acid. Okay, and then if you look back, just in case you don't remember, okay, water is your conjugate acid. So you have to be able to properly label these to know what to look for on the table. Okay, so we're going to compare HCN and the conjugate acid, okay, which is water. So there's our conjugate acid. Okay, if you look at your arrow here, water, okay, this is the weak conjugate acid. Okay, so because water falls below our HCN there, it is weaker. You can see how it gets stronger as we go up the table. All right, so now we know that. We know water's the weaker acid. So what I've been discussing in this video is the reaction always drives to the side of the weak conjugate acid. So it's going to drive towards water. Okay? So we looked at our table and we compared our acids, and we know that water is weaker, therefore products are favored. So your arrow is shifted towards the products. Okay, we're going to do one more for practice. All right, so if you have your table printed or can get access to it, I'll try to flip back to it. Okay, I'm going to show you the problem first, and we want to know if this is reactant favored, we see our equilibrium, or if it's product favored. So the first thing we have to do is we have to label. So if we look at our acid list, this is carbonic acid. So this is our acid. Okay, this is our base. Okay, bases gain protons, right? So this is its conjugate acid. Acids lose protons. So this is the conjugate base. Goes from the neutral to negative. This is negative and it gains a positive, so -1 + 1 makes it neutral. Okay, therefore we still have a negative charge total on the right hand side and a negative charge total on the left hand side. Alright, so everything's labeled, but we're going to compare acid to conjugate acid. So we have carbonic acid and acetic acid. Okay, our rule is that the equilibrium drives to the side of the weak acid. So we need to go and look and see which one is weaker, carbonic acid or acetic acid. Okay, here is carbonic and here is acetic. Okay, carbonic is weaker, right? Because as you move up, it gets stronger. So carbonic acid is weaker than acetic acid. So if we look here, this is weaker. Okay, and so because it is weaker, we know the equilibrium is going to drive to the weaker acid. Therefore, it's going to drive this way. Okay, and this would be reactant favored. Okay, so label your reaction, your acid, your base, your conjugate acid, and conjugate base, and then compare your acid to your conjugate acid, or just compare your acids and see which one is weaker. Okay, and the one that is weaker, that's the way the equilibrium is going to lie. Okay, and so in this situation, carbonic acid's weaker, therefore this is a reactant favored reaction, and your arrow would be larger towards your reactant side. All right, I hope this helps. Thank you.